Alright, this is 7.2, part 1. These are all going to be U-try problems. So, the very first one, let me zoom in here, has this bounded region, and then I'm going to revolve it around the line y is equal to -4, so you can at this time pause it and try the problem yourself. So Scout's honor that you've actually tried this problem yourself, and I'll go over the answer. So first thing I want to do is create a graph of this. So let me pull up this graph. So this is what the region looks like. So I'm looking at spinning this region about the line y is equal to -4. So the region is being revolved and it's being spun this way. So I want to go ahead and draw my sample rectangle. So the rectangle starts where I'm spinning, which is at -4, and it ends at the very top of the region. So it's going to be going from -4 all the way to this very top, and it has a little curvy top like that. And this is the shaded part. And notice there's no empty space, so it's going to be, in fact, it's going to be a disk. So I go ahead and set up my problem for a disk. So my sample rectangle has a flat bottom, which is the line -4, and then a curvy top from the -x to the third over 2, and this is -4. So I can set up my integral as the volume v equal to pi. The integral, I'll look at the limits of integration in a moment. Then it's going to be the top minus the bottom, so it's going to be -x to the third over 2 minus a -4. So it's going to be -x to the third over 2. Because I'm subtracting a negative number, it's going to turn out to be +4. And then the radius is being squared with respect to x. And then I look at my graph to see that my limits start from 0, which is over here, and it ends at x equal to 2. So it's going to be the integral from 0 to 2. So going back this way, my integral is going to be 0 to 2. And again, you would evaluate this integral on your graphing calculator. You wouldn't evaluate it by hand. So you're going to find this value on your graphing calculator. And here is what the revolution looks like. Let me back this up, and there it is. So you can kind of see how the two regions, or how the sample rectangle looks, comparison to our approximation over here based on our crude sketch. Alright, so going over now the next one. Let me go ahead and pause that. The next one has this as the region. So let me move this a bit. Okay, so go ahead and pause that one, give it a try. And so same as before, I want to go ahead and sketch what this region looks like. So let me pull in the region. So there's the straight line, which is x plus 3. Here's the parabola x squared plus 1, and then the horizontal line y is equal to 6. So it's going across this way. So I want to draw my sample rectangle to notice if there's any empty space. And it turns out for this one, because it's being revolved around y is equal to 6, going around this way, I start at 6 and I go to the very edge, and the very bottom of it is a parabola, and it's going to be this shaded part in between. And notice there is going to be some empty space, so it's in fact going to be a washer. So let me move this over here. So it's going to be a washer. Alright, so let me draw my sample rectangle over here nicely. So it has a curved bottom and then a straight line going across this way, and it's going to be the x plus 3 as a slanted line. This is what's shaded. So this is 6, this is x squared plus 1, and this is x minus, or x plus 3, excuse me. Alright, so to identify the entire and the empty, let me move this over. The entire is going to be 6. So the entire is going to be the very top minus the very bottom, so it's going to be 6 minus parentheses x squared plus 1, which I can then simplify to be, well, when I distribute the negative, it's going to be minus x squared minus 1. So I have a 6 and I have a minus 1. So this simplifies to be 5 minus x squared. So that's going to be my entire radius. As far as the empty starts at 6 and it ends at x plus 3. So let me write the empty over here. So it's going to be a 6 minus parentheses x plus 3. And then simplifying this a bit, I can distribute the negative, so I get negative x minus 3 and then 6. So this is going to be 3 minus x for my empty. So my integral setup is going to be, the volume is going to be pi. I'll worry about my limits of integration in a moment. The entire radius squared. So it's going to be 5 minus x squared parentheses squared minus the empty, so 3 minus x parentheses squared dx. I look back at my given graph and I notice that the limits of integration are going to be where they intersect, which is negative 1 and positive 2. So my limits are negative 1, positive 2. And then again, the integral would be evaluated on your graphing calculator. And let's see what this region would look like if I can pull up the video. So let me bring this up over here and zoom in a bit and compare it to our approximation, and this is what it would look like. So that's it for the two U-try problems. Hopefully you were able to set them up correctly, and tomorrow we'll have additional practice with both discs and washers, and then we'll throw in some of the bases problems for tomorrow.